With linear functions, we found that the rate of change was given by the slope. We will now look at average rate of change. The idea of average rate of change will let us use what we know about lines to get a new understanding of all functions. As we said, for linear functions, the rate of change is called the slope, and it is always the same between any 2 points. What about functions that aren't lines? Below is the graph of the population of Holyoke from 2000 to 2008. Clearly, this is not a line. How do we interpret rate of change for this function? Rate of change is the change in population per year. Can we quantify the rate of change even though it is not a line and we don't have a slope? Can we find what the rate of change in population is from 2000 to 2002? In those 2 years, the change in population, or delta P, is 441. In other words, the population of Holyoke grew by 441 people. So, on average, the population grew by 220.5 people per year. We calculate this by taking the total change in population divided by the number of years that population grew. What we just found is that the average rate of change in population per year can be calculated as the change in population divided by the change in time, which for this example is 441 divided by 2. So we say the average rate of change in population is 220.5 people per year. For any function y equals f of x, the average rate of change between 2 points x1, y1 and x2, y2 is calculated the same as the slope of a line, which is delta y divided by delta x, or y2 minus y1 divided by x2 minus x1. The only difference now is that instead of calling it slope, we call it the average rate of change between x1 and x2. It is worth noting that the units of rate of change, average rate of change, and slope are all the same, and are given by the units of y divided by the units of x. Let's continue our example and find the rate of change in population from 2002 to 2004. In those 2 years, the change in population, or delta P, is 272. So on average, the population grew by 136 people per year. Let's now find the rate of change in population from 2004 to 2006. In those 2 years, our change in population, or delta P, is only 67. So on average, the population grew by 33.5 people per year. What about the average rate of change in population in the last 2 years? In those 2 years, delta P is negative 358. This means that the population shrank by 358 people. Or on average, the population grew by negative 179 people per year. In other words, the population shrank by 179 people per year. Let's recap what we just found out. From 2000 to 2002, the average rate of change was 220.5 people per year. From 2002 to 2004, the average rate of change was 136 people per year. By 2004 to 2006, the average rate of change was only 33.5 people per year. And from 2006 to 2008, the average rate of change was negative 179 people per year, which we interpreted as a loss of 179 people per year. It is crucial to note that the average rate of change is different between each pair of points. For lines, the average rate of change, or slope, is always the same. We want to think of rate of change as keeping track of slope, even if it changes.